Hi class, this is section 10.4, polar coordinate graphs. So in this section, we're going to look at how to graph polar graphs. So just in like rectangular coordinate system, we test for symmetry in the polar coordinates, just to simplify our graphing. So there's 3 tests to perform when you're looking for symmetry. So if you're looking for symmetry about the y-axis, which is also known as the theta equals pi over 2 line, then you're going to replace r comma theta with negative r comma negative theta. So you just simply replace the r with negative r and the theta with negative theta, and then you simplify the equation to see if you get the original equation back. If you do, then that means it's symmetric with respect to the theta equals pi over 2 line, which is also known as the y-axis. All right, for the second symmetry test, you to see if there's symmetry over the x-axis, also known as a polar axis, you want to replace r comma theta with r comma negative theta, or I don't know why you would do this, but it also works if you replace theta with pi minus theta. But I highly recommend that you just simply replace it with r comma negative theta. Okay, it's much easier to do it that way than it would be to do it this other way. All right, and the last symmetry would be with respect to the origin, also known as the pole. So you want to replace r comma theta with negative r comma theta. Okay, and that's the final test. Okay, so this is what symmetry would look like. If you're looking at symmetry over the theta equals pi over 2 line, that would look like this. See how this gets reflected over the y-axis? If you're looking at polar axis symmetry, that means that you would reflect this over the x-axis, just like that. And origin symmetry would look like this, directly across the origin. Okay, so those are the 3 different types of symmetry that you could possibly have in a polar graphs. Okay, let's look at this first example. They give us an equation. It's in polar form, as you can see, and we need to test all 3 types of symmetry. So let's start with the first one, which is that would be the theta equals pi over 2, which is also known as the y-axis. Let's say symmetry. That's going to be the first test. Okay, and if you recall, you're replacing both r and theta with negative r and negative theta. You can look up above if you need to remember that. So let's do that now. So instead of r, you replace it with negative r. Instead of theta, you replace it with negative theta. If you recall, cosine is an even function. So I'm just going to make a note here. Cosine negative theta is equal to cosine theta. We learned that a while back, so that's something you want to try to remember. So that means that negative r is equal to negative 2 cosine positive theta. Solve for r by dividing by negative 1 or multiplying both sides of the equation by negative 1, and you get positive 2 cosine theta. And now compare that to the original equation that we started with, and as you can see, they're not the same. So that does not equal negative 2 cosine theta, which is the original equation we started with. Therefore, it fails that test. So there's no symmetry about the y-axis. Okay, all right, now let's perform the second test to see if there's symmetry over the polar axis, also known as the x-axis. So we'll call that polar axis symmetry. Okay, so for that test, we replace theta with negative theta. That's all you do for that one. So r stays the same. Theta becomes negative theta. And once again, cosine is an even function, which means that negative 2 cosine of negative theta is equal to cosine positive theta. And as you can see, that does equal the original equation that we started with, negative 2 cos theta. You can see that right up here. This is the original equation that we started with, and sure enough, it is the same. So therefore, there is, this one passes the polar axis symmetry test. Okay, so there is going to be polar axis symmetry. Let's just highlight that to kind of emphasize that there is polar axis symmetry. All right, the final test is going to be the origin symmetry or the pole symmetry. So let's write that. And for that one, we just replace r with negative r. So let's do that now. So r becomes negative r. Theta stays the same. Divide by negative 1 to solve for r. And we end up with r equals 2 cos theta, which, if you compare it to the original function or equation, does not equal negative 2 cos theta, which means it fails this test. So there's only polar axis symmetry in this problem. And once again, you can look at Desmos to verify that. If you type this into desmos.com, you will see that the graph does have x-axis symmetry, polar axis symmetry. Okay, let's move on to the next page. So now they're going to show us how to graph by plotting points. So when you're graphing a polar equation, you want to construct a table consisting of thetas and r values. All right. They also tell us to first find zeros by setting r equal to 0. So we start there. You set r equal to 0, and then you solve for theta. And then the second thing that you want to do is you want to find the maxima. That means that you want to find the values of theta that maximize the trig function. So you simply replace sine theta with 1 because that's the maximum that sine theta could be, and also cosine. The maximum value of cosine is also 1. So you just replace those two functions with 1. Okay? Okay. So there are some classic curves, such as circles and cardioids. All right? So anytime that you see a formula that is of this form, r equals a cosine theta, or r equals a sine theta, you should automatically know that that's going to be a graph of a circle, okay, where the diameter is a, which means that the radius would be half of that, a over 2. Okay, and for a cardioid, which is a heart-shaped graph, it's going to take on the form of a plus or minus b cosine theta, or it can also look like a plus or minus b sine theta. There is a condition for that to actually be true. For it to take on the shape of a heart or a cardioid, a and b have to have the ratio of 1. So that means that a and b have to be the exact same number. A divided by b must equal 1 in order for it to have a cardioid shape. Okay, the graph will pass through the pole, which is the origin, right? Okay, so let's graph cardioid right now. Down below, this is the example we're going to do now. So let's start with the first thing that we should probably do, which is find the zeros. So remember, to find the zeros, we are going to set the r equal to 0. So 2 plus 2 cos theta equals 0. If you solve for cosine theta, you're going to get subtract 2 divided by 2. You should get cosine theta equals negative 1. And that's going to occur when theta is equal to pi. Okay, and then the other thing, let's find the maxima. So that means replace cosine theta with 1, right? So if you replace cosine theta with 1, and that's going to occur when theta is equal to 0, right? When theta is 0, cosine is 1. And so if you replace that, you should get r equals 2 plus 2 times 1, which is 4. So the maximum value is going to occur at 4, 0. So now we have our maximum point, and we also know when the zeros occur at basically any multiple of pi. Okay. And if you want to test for symmetry, you can. I'm just going to kind of tell you that the symmetry for this graph is going to be polar axis symmetry. You can perform the polar axis test on it, and you will see that it does pass the polar axis symmetry. So because it's symmetric over the x-axis, when you're choosing your points, you only really have to choose points from 0 to pi because of the polar axis symmetry. And then you can just basically reflect that graph over the x-axis, and you don't have to do the pi to 2 pi values because of the symmetry. That's the benefit of knowing of performing those symmetry tests. It kind of reduces the amount of work that you would have to do by plotting points. So now let's get to the plotting points part. R theta, R comma theta. Let's do 3 columns. All right. So let's start with theta. Let's start with values for theta. So let's start with 0 because that's just, that's where you usually start. Theta equals to 0. And then we can go to pi over 4. Let's just pick some values. And then we'll go to pi over 2. It's basically just increase theta gradually. I'm going to choose some convenient values that are going to give us some nice points. Like 2/3 pi, you will see will give us a nice point. All right. And then finally, let's just go straight to pi. And then after pi, we just reflect that graph over the x-axis because of the polar axis symmetry, and we have our graph. Okay, so once you've chosen values for theta, then you can simply plug them into the equation. So if you plug in 0 in for theta, you're going to get 1. 1 times 2 is 2. 2 plus 2 is 4. So I'm going to save us a little time just by plugging in the values of theta, but you should definitely do this on your own. Plug in pi over 4 into theta. Evaluate this. Use a calculator if you want, or you can use a unit circle. But you do want decimals because we're graphing, so you're going to need to use decimal representation. So I would encourage you to plug in these values into this equation and make sure you're in radian mode. Make sure your calculator is in radian mode. And so I'm going to give us the values because I've already done this. On my calculator, I'm getting 3.41 for this one. I'm getting 2, I'm getting 1, and 0. So these are going to be the points that we're going to graph or plot. And we already know how to graph polar points and polar coordinates, so that's good. Okay, so this is kind of where it gets a little bit interesting. So the first point is 4 comma 0, so that would be 0, angle 0, and then 4 units out. All right, for the next one, you're going to pi over 4. Remember, pi over 4 is 45 degrees. So out here, this is 45 degrees, 3.41 units out. So 1, 2, 3.41 is approximately here somewhere. So let's put a point there. About right here, I would say. Almost halfway. Okay, and then the next point is 2 comma pi over 2. That's easy. You just go to the pi over 2 line or angle and then go up 2 units. All right, the next one's going to be 2/3 pi, which is 120 degrees, and you want to go 1 unit out. So that would be about right here. All right. And then the next one is, or the last one is 0 pi. So at pi, it's 0, which represents the pole. Okay, so if you graph this, you just want to connect those in a very smooth, or actually, before we connect them, let's graph the reflection of those points over the polar axis. So this one would reflect down here somewhere. This point would reflect down here. This point would reflect right across the x-axis, and the origin stays at the origin. So all I did was I simply started here, and I went down to reflect, reflected, reflected. And now we can connect these points, and you'll have your cardioid. So this is the hard part because you have to have a very steady hand like a surgeon. All right, it's not the best graph, but it does resemble a heart, as you can see. So that's how you go about graphing these type of graphs, polar curves. All right, let's turn the page and get to the next slide or page. All right, so these are called, I'm not going to do this justice, limicons. It's a French word for snail. So generally they have the form of a plus or minus b cosine theta, all right, or a plus or minus b sine theta. Okay, so this is going to occur, there's going to be 3 different versions. So you either have the ratio a over b, which is between 1 and 2. That's going to give you a 1 loop, okay? And then the one that is called an inner loop would be when, let's see, that's going to be when b is greater than a. So when b is greater than a, then you're going to get that inner loop. And you'll see examples of this. So, and then the last one is called the convex one. That's when A and B are greater, the ratio is greater than or equal to 2. So here's what the one loop ones look like. That would be this first figure down here, these four. And depending on whether it's cosine or plus or minus, that's going to indicate where the graph is. All right, if it's minus and there's a sign involved, then it's on the bottom. If it's plus and it's sign, then it's on the top. If it's minus and cosine, it's on the left. And if it's plus cosine, it's on the right. That's called a one loop limicone. I'm not sure if I'm saying that right, but all right, this would be an example of an inner loop. And same idea, there's four different versions depending on whether it's plus or minus or cosine or sine. Okay, so let's look at our first example of one inner loop, of inner loop limicone. So it's going to be a plus cosine, so we should expect it to look something like this on the right side, right? Because of the plus and the cos, plus and the cos, it should look like this one, the first one on the left. Okay, so let's start with what we should do first, which is to find the zeros. So let's find the zeros first. All right, so 2 plus 5 cos theta equals 0. You should get cos theta equals negative 2/5. In this case, negative 2/5 is not a ratio that we recognize as a special position angle on the unit circle, which means we have to do the inverse cos on our calculators. Make sure you're in radian mode. So if you do the inverse cos of negative 2/5 on your calculators, you will get theta is equal to 1.98. All right, so that's where the zero occurs. All right, and then for the second thing that we should do is let's find the maxima. So that occurs when cosine theta is equal to 1. In other words, when theta is equal to 0. Okay, so that's going to occur. Let's see, so let's replace cosine theta with 1. You should get r equals 2 plus 5 times 1, which means r is 7. So at 7 comma 0, that's the maximum value. All right, now we can go ahead and plot some points by creating an r comma theta table. So let's do that. R theta, r comma theta, just like we did last time. And remember, we're selecting values for theta. And once again, because this is a cosine, you can perform the symmetry test, and I'm going to save us the time, but I will let you know that this is going to have polar axis symmetry again. Okay, so I'm going to select some values for theta. That's how you should start. So let's always start with 0. All right, and then we can kind of increase theta gradually. This time I'm going to go with some other values, extra values, pi over 6, pi over 3. This is entirely up to you, the amount of values that you want to plot so that you can get a more accurate graph. So I'm going to give us a lot of values here. Pi over 2, 2/3 pi. The more the better, actually. 5/6 pi. Let's see, 7/6, well, pi. 7/6 pi is a good one. We're just continuing to go down, increase our angle. Oh, let me switch, sorry. Okay. All right, so the next angle we'll look at will be 4/4 pi, 3/2 pi, 5/3 pi. I'm just going around the unit circle, and I'm selecting values so we can get a nice graph. Okay, now let's extend these lines down a little further. And once again, you know what you're supposed to do is plug in these values into theta and then solve for r, right? So you plug in these values. Since I've already done this, I'm going to save us the time, but I highly encourage you to double check my values to make sure that they are the same values that you are getting. Okay. because of the symmetry, you're going to see a lot of the same values because of the symmetry. After pi, you're going to see a lot of repeats. Actually, you're going to see the identical points because I really didn't have to go beyond pi because of the polar axis symmetry, but just to get this one's a little trickier to graph, so I think it's beneficial to graph beyond pi in this case. All right, so negative 2.3. Oops, let me see. Did I do that one right? Actually, that one should have been 2. Okay, let me backtrack here. Okay, so that one should be a 2. This one should be a 4.5. This one should be a 6.3. And this one should be a 7. Okay, so once again, let's do the same thing. Let's start with the first one. I will, you can choose to skip this step if you want to. I like to do it, though. It makes it nicer because you know exactly what points to graph. For the sake of time, I'm just going to put ... You know what to do here. Okay, so the first point, it looks like the max is 7, and our scaling is going by 1. So what I'm going to do is I'm going to change the scaling to increase by 2. So this would be our 1, 2, 3, 4, 5, 6, 7, 8. All right, so just because it's not going to fit, we're going to have to extend this out if we leave it scaled the way it was. So 7, 0 is right here. 0 degrees, or sorry, 0 radians, 7 units out. The next one's pi over 6, which is 30 degrees up. Here's your 30 degree pi over 6 angle. 6.3 would be a little bit more than 6. So we're going to put that point approximately. Obviously, it doesn't have to be perfect. It's really difficult to get these perfect. It's impossible to get them perfect because we're not computers. All right, the next one would be pi over 3. That's 60 degrees, 4.5 units out, so that's 4.5. That would be approximately 4.5 would be somewhere like right here. Okay, the next one is pi over 2, so that one's nice and easy. There it is. Okay, the next one's going to be 120 degrees, which is 2/3 pi, negative a half. So because it's negative, instead of going out in the 2/3 pi direction, which is approximately here, instead of going out this direction, the r is negative, you have to go the opposite direction. So it's going to be more like over here somewhere. So you have to just be careful when you're graphing these because of the negative r's. Okay, the next one's going to be, well, I'm just going to continue this process, and then you will see that it's going to look like what kind of shape it starts to take. All right. So now I'm going to start reflecting points, just kind of because we already know there's polar axis reflection. And you can also use Desmos to help you out, just to make your lives a little easier. I do recommend, especially when you're doing homework, to use Desmos to kind of verify all this. Verify that these are the points that are the ones that we're graphing. Okay, so now it's time to put this all together. So it starts here and it goes in this direction. It goes like this. It does a nice little, whoops, it does a nice little loop. It goes back, and it goes like that. So that's our inner loop. So that should look like this, which it does, as you can see. Okay, let's move on to the next page. Okay, so, whoa, all right. I don't know how to pronounce this word, but I think it's lemni skates, like lend me some skates, because I'm going to go ice skating. I'm just going to refer to it as a figure 8, and it's going to have this kind of form over here. R squared equals a squared cosine 2 theta, or it can also take on the form of r squared equals a squared sine 2 theta. And the graphs of these look like a figure eight, infinity symbol. Based on the A, whether it's positive or negative, it'll either take this orientation or this. And if it's a sign, then it will kind of reflect over the pole, just like this one. Actually, all of these reflect over the pole, okay? All four are symmetric with respect to the pole. All right, let's continue down to see what other graphs are shown. These are really nice. These are rose curves. Okay, so rose curves have these type of formulas. R equals A cosine n theta, n can be any integer, or R equals A n sine theta. If n is an even number like 2, 4, 6, then the curve is going to have 2 times n number of petals. So double the amount of petals, whatever n is. Let's say n is 4. So if n is 4, then that means you're going to have 8 petals. 1, 2, 3, 4, 5, 6, 7, 8. So this one here, n is 4. Okay, because it tells you here. It's even, therefore you double the amount, and that's the number of petals that you have. When n is odd, the curve is just going to have that number of petals, n petals. So if n is like 3, then that means you're going to have 3 petals, like this one over here. If n is 5, then you're going to have 5 petals, etc. Okay, let's continue. Let's go to the next page so we can actually try a graph. Okay, this one is a little bit harder, requires a little bit more work, but we still do the same thing. So it turns out this graph here, it's going to look like, since n is even, n is 4, that means there's going to be 8 petals. So there's going to be 8 petals that we have to graph. Okay, so let's start with symmetry. So we'll start with symmetry. All right, so this graph, you can perform the test. I'll save us the time, but it's going to have all 3 symmetries are going to pass the test. So it's going to have pi over 2 symmetry, which is y-axis symmetry. It's going to have polar axis symmetry, which is x-axis symmetry. And it's also going to have pole symmetry, which is origin symmetry. So it passes all 3 tests. You can verify that. Okay, now let's look at the zeros now. So set the function equal to 0. So you get 2 cos 4 theta equals 0. Divided by 2, you get cos 4 theta equals 0. So that means that the argument 4 theta, cosine is 0 at 0. So that's going to occur when the argument is equal to, at pi over 2. Cosine is 0 at pi over 2. So that means you set the argument equal to pi over 2, divide by 4, and you should get pi over 8. All right, so that's when you're going to get zeros. Okay, right, so in other words, when theta is pi over 8, you're going to get a 0. Okay, all right, now let's find the maximum. Well, the maximum we know occurs when cosine of 4 theta is equal to 1. So let's find that maximum. I'll call it maxima. Okay, so just replace cosine 4 theta with 1, and so that's going to happen at 2. So the largest value for r is always going to be 2 because of that fact. Okay, now it's time to plot our points. So let's go to our table. Let's construct a table, r theta. R theta. This time I'm not going to do the r comma theta because it's just too much writing. It's up to you if you want to. If it helps you, then definitely you should. If it doesn't really help, then you don't really need it. Okay, let's go ahead and start with 0 like we always do. All right, and then we're gradually going to increase our theta. Because of the zeros occurring at pi over 8, you actually want to make sure that you're going up by pi over 8 each time. So this is a great strategy. So you're going to go pi 8s, 2 8s, 3 8s, 4 8s, etc. all the way until you get to 2 pi, basically. So that's basically the strategy. That's the benefit of finding the zeros, because it tells you how much to increase your theta by each time. So in this case, it's going to be pi over 8, and then 2/8 pi, 3/8 pi, 4/8 pi, etc. until you get to 2 pi, all the way around the unit circle. You can simplify these if you want. I'm going to choose not to, but you can. It's completely up to you. And you're going to see what happens. You're going to start to see a pattern emerge. And then once that pattern emerges, it's just going to allow you to get through this a lot faster. Okay, but I'm going to just continue till I get to 2 pi, which is now 16/8 is 2 pi. Okay, now let's find those values that correspond to those angles. Once again, all you have to do is substitute the angle into this equation, and then you'll find your R values. So I'm going to save you the time, like I've been doing throughout this video. It's going to be 2, 0, -2, 0. And then it just repeats. 2, 0, -2, 0. 2, 0, -2, 0, etc. It just continues, and you'll see how that plays out when you graph 2, 0, -2, 0, 2. All right, so let's begin. The next thing that is really helpful is to kind of identify the pi over 8 angle on the graph. So pi over 8 is approximately, it's going to be over here somewhere. It's going to be less than 30 degrees, right? Because pi over 6 is 30. So pi over 8 is a little less. So I'm just going to make some marks here for the time being so you can see what I mean. So I'm going to estimate that pi over 8 is like here somewhere. And then you got 2/8 pi. 2/8 pi is pi over 4, actually. And then you got 3/8 pi. And then you got 4/8 pi. That's this one, pi over 2. 5/8 pi is going to be over here somewhere. 6/8 pi is this one. 7/8 pi. 8/8 pi is pi. 9/8 pi. 10/8 pi. 11/8 pi. 12/8 pi. 13/8 pi. 14/8 pi. 15/8 pi. And finally, 16/8 pi, which is 2 pi. Okay, now time to graph. 2, 0, 0 radians, 2 units out. There's our maximum value. And then at pi over 8, at this angle, at this angle, you're going to go 0, R. So it's basically the pole, right? So there it is. So far it's going to look like this. It's half of a petal. All right, and now the next point is 2/8 pi. So at this angle, you're going to go -2. So instead of going out +2, you're going to go -2. So here is the next point. All right, so it's essentially graphing this petal now. And then look at the next point. The next point is 3/8 pi. At this angle, you're going back to 0. So now it's going back to 0. So now we've completed it. And then at pi over 2, you're going to go 2 units out. That's this one right here. At 4/8 pi, you go 2 units. Boom. All right, so now you're going to start this petal. All right, and then at 5/8 pi, you're going to go back to 0. And then at 6/8 pi, you're going to go to -2. So that's going to be this angle over here. Or it's the negative. So instead of going in the 6/8 direction, you can go in the opposite direction because of the -R. And then back to 0. As you can see, the pattern just repeats itself. And then at 7/8 pi, oh, that's 0. And then at pi, you're going to go to 2. 1, 2 for pi. That's going to start to draw this petal. And then back to 0. And then at 10/8 pi, 10/8 pi is this one right here. You're going to go -2. So instead of going this way, you're going to go in the opposite direction. So it's going to start to graph this petal over here. And then back to 0. And then that takes care of 11. Now 12/8 pi. 12/8 pi is 2, so that would be down here. So it's going to start to draw this petal and then back to 0. And then 13, okay, then 14/8 pi. At 14/8 pi, it's going to be -2. At 14/8 pi, we're going to -2. So here's 14/8 pi. Instead of going in this direction, going in the opposite because of the -r. So that's going to start to graph this petal. And then back to 0. All right, and then finally, the last one, 16/8 pi, to complete our graph is right there. So you can count the number of petals. 1, 2, 3, 4, 5, 6, 7, 8. And remember, there should be 8 petals because n is 4. n is 4. And we know that if n is even, then the number of petals is twice that amount, which is 8. Okay, so that completes that one. The last type of graph we're going to look at is called a Archimedes spiral, after the famous philosopher, intellectual, I don't know what you would call him, person from ancient times, Archimedes. So he came up with this. So the formula is really simple. It's just r equals theta. As theta increases, r is going to increase at a constant rate. So it just creates this like spiral shape that you see here. And if you continue just to increase, this is only from 0 to 2 pi, but if you continue to increase to 4 pi, it's just going to continue to get larger and larger and larger and so on. So let's take a look at our last graph on the final page of this section. Okay, so for this one, you don't really have to do anything other than just create a table of values like we've been doing, r comma theta. And I'm not going to do the third column. I'm just going to go from 0 to 2 pi because that's all they're asking us to do, as you can see by the interval. So we just start at 0 and increase gradually. I'm going to go with 0, of course, pi over 4, pi over 2, pi, 3/2 pi, 7/4 pi, and 2 pi. And remember, you can add as many angles as you want. You can go literally through each of those special positions, pi over 6, pi over 4, pi over 3, pi over 2, 2/3 pi, etc. on the unit circle if you'd like, just to get a more and more the more angles you choose, the more points that you'll be plotting, and so your graph will be more accurate. All right, so same thing. If you plug in theta, 0 for theta, you get r equals 0. So these are always going to be the same because r equals theta in the equation. So whatever theta is, that's the same thing for r. So these are going to be identical to theta, which makes it really simple, right? You don't have to plug in values and use your calculator at all. So it's kind of nice. All right, and so now let's go ahead and graph this. So actually, I should have gotten the decimals. Yeah, for r, you want decimal representations of this. So let's write these in decimal form. Let's just approximate. All right, so 0 is 0. Pi over 4 is 0.785. Pi over 2 is 1.57. 3.14 for pi, etc. 5.5 for this one, and 6.28. So it makes it easier when it's in decimal form. So 0, 0, that's just the origin or the pole. Pi over 4, 0.785, that would be approximately in the 45-degree angle, not quite 1. Okay, pi over 2, that's 1.57, so a little bit more than 1.5 would be up here. In the direction of pi, you want to go 3.14, which is about here somewhere. 1, 2, 3, plus a little bit extra. All right, in the direction of 3/2 pi, you want to go down to 4.71. 1, 2, 3, 4.71 is going to be somewhere over here. You can draw some more concentric circles if you'd like. And then finally, 2 pi is 6.28. That's going to be somewhere out here. All right, then you just kind of create your spiral. Okay. That last part didn't look very nice, so I'm going to try to fix that last part. Okay. Somewhere over there. Hopefully you guys get the point here, even though my graph isn't the best. All right, and that completes this section.